Hello, and welcome to Sterling and VMware's PowerBlock session. I am Megan Moore, Sterling's VMware Partner Business Manager. We know your time is valuable, so we want to thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with industry best value on all of your client to cloud needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies and more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal, state, and local government contracts and support all industry verticals. Sterling is security is of the utmost importance at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases that you will find at the end of the demo. For questions during the demo, please put them in the Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architect Nathan Bennett to demonstrate Terraform with VMware's NSX-T and vSphere.
Thank you so much, Megan. And thank you everyone for joining us today. If anyone's wondering who I am, I've spent a number of years in the automation space. So when we talk about security, when we talk about automation, as well as a bunch of buzzwords like DevOps, DevSecOps, GitOps, a lot of those different buzzwords. I play in that space and I really enjoy working in those areas. So you can see here different contacts that you can reach me at. I am very active in Twitter, so you can always reach me there or send me a DM if there's any questions or anything along those lines. I also write for the Sterling blog, which you can look at this link. We have a number of different blogs with different solutions and things that we do to kind of show what we can do for customers. The latest one that I've written is based off of SaltStack and vRealize automation. And I'm sure that there'll be something in a PowerBlock session later on. So please stay tuned for fun stuff like that coming down the line. In terms of the agenda for today, we're going to go through a number of slides that basically go over a very high level of what we're going to be doing today in the demo, what Terraform really is, and kind of some pro cons between Terraform and some other solutions that are out there, a little bit on why DevOps is really so awesome, why I love it so much, and why I'm a big advocate and evangelist for it. And then we're going to get into the actual demo. And for our demo today, we're going to be deploying onto vSphere and NSX-T, as y'all saw. And we'll be using Terraform to deliver that. We're going to be deploying a Terraform WordPress application. So this isn't just infrastructure as code. We're also going to deploy within the operating system itself and deploy the Terraform WordPress application within 3 different vSphere machines, which is one going to be the SQL backend, and then 2 for the front end web. And then for networking, we're going to use NSX-T for the load balancer, as well as creating the necessary backends for everything that follows along there, including the firewall and the T1 router and things along those lines. So just to give kind of a very high level of what we're going to be seeing, we're going to be utilizing my own computer. I like to think this is what I look like, but maybe not so much. But we're going to be using a manifest that's just local on my computer. We're not going to be using anything spectacular with like Git or the repositories. We're just going to use a very simple manifest in order to deploy to vSphere. And that manifest is going to be utilizing, of course, Terraform CLI to initiate the backend and to create the necessary state files from this manifest. And then Terraform is going to call out to the different providers that are necessary to create both the vSphere VMs that need to be built, as well as the NSX NSX-T pieces that need to be built. And so that kind of shows you in a little bit of a different way how Terraform is really the orchestrator that calls all of these different things. When we get into the actual demo, we'll talk a little bit more about why Terraform, how I'm setting these things up, and how Terraform calls to the different providers, because Terraform really has kind of a mind of its own in terms of what is dependent on other pieces. And we'll kind of dive into that a little bit and take a little bit of a deep dive into the code in those areas. So let's take a look at Terraform. And at a very high level, what I always like to think about with Terraform is the word idempotence. For some that don't know that word, just think of it as getting the same result every single time you click the button. And that in the automation world is fantastic. If you think of something like Dude Perfect, right? If you've ever seen one of those YouTube clips where they're, throwing a ping pong ball and it's bouncing all over the place and then it falls into a hole at the end. That's really cool. It's really awesome, but it's not repeatable. It has to be very specific to do that every single time. And so in automation, you can kind of run into things like that because you can create these amazing pipelines and things that can do all sorts of amazing stuff, but is it repeatable? Is it accurate? How well does it get to the endpoint? And those are the things that, when you're looking at tools and products, lead to the pros and cons of different tools that are out there. Now, Terraform is one of the best in terms of idempotence because it understands everything in terms of a state file and its back end. And we'll dig into a little bit more about that, but I don't want to get ahead of myself. In terms of what Terraform actually does outside of doing the same thing every time, it's a cloud agnostic multi-provider tool. Now, I want to be very clear about a couple of things. Terraform is not specific to any cloud. So when we're talking about cloud, I mean your private cloud as well as public cloud. But even on top of that, we always think of it as infrastructure as code, but people always think infrastructure is just maybe a VM. And that's not the case. Obviously in this, we're using Terraform to deploy networking components as well. And that flows in with a lot of different things that Terraform can utilize to call to many different providers. You can see here that there's over 740 providers, and it continues to grow. They've even started working in the Kubernetes space in order to use HCL, which is a HashiCorp control language, in order to deploy your deployments and pods within a different type of language schema instead of YAML or JSON. So there's so many different ways that people are using Terraform right now. It's really interesting to see. Terraform is a declarative language. If in the automation space, we love declarative languages because it makes our life so much easier. When we say declarative, it basically means that there's an understanding underneath what you're writing in the code. So if I say to build a AWS AMI, it knows what it's looking to build. I don't have to say, look for this AWS AMI. This is where AWS is. This is what an AMI looks like. This is what its GUID it looks like. This is what all these other components of it looks like, and have to list out multiple different attributes. So the analogy that I use here is declarative is kind of like just saying, make a taco. It knows what the components are of a taco, and it knows how to assemble it. The opposite of this is imperative, which I liken more kind of feeling your way through the dark, because you really have to work through the objects and attributes of those objects in order to create the automation for it. For instance, if we continue with the taco idea, if you want to make the object of a taco, you have to list the attributes of that, which is, meat, cheese, taco shell, lettuce, tomatoes, et cetera, et cetera, et cetera, et cetera. And then you have to build that out within your code base before you can even say, now go make the taco. And now you can clearly see here how using this declarative language makes your life so much easier. Terraform has its own enterprise solution that they can utilize for on-prem with much better security practices. For instance, what we're using here Today is going to be using a VAR file, which is really kind of the worst way to do security, but it's a demo. So do what I say, not what I do in this demo. We're going to show later on in another power block a couple of weeks from now about how Terraform can also use a different product in order to store the state file and better security for your variables by using vRealize automation with its plugin for Terraform. So stay tuned for that. That's going to be a couple of weeks from now. That's going to be really fun to go through. Terraform will also announce that they are available for on-click use cases in the public cloud. I think Azure and AWS are what they're using with the what they call it the HCP, or the HashiCorp Cloud Provider platform. And so it allows them to deploy Terraform Enterprise, and then you can start utilizing it within those public clouds. So there are other ways to utilize it there. So when we talk about providers, I wanted to bring this up so we could see all of the different VMware providers that we have. And I want to make a couple of notes here about the types of providers that are out there. They're classified in 3 different ways. One is a verified provider, and these providers are provided by HashiCorp, and they're kind of monitored and managed by HashiCorp. So they have people that are actually working there that make sure that this provider is running the way that it should be. That's pretty much the top tier of the providers that are out there. Then you have the open source providers. These providers are not HashiCorp monitored and managed, but they're normally managed by the company that is being utilized. So for instance, you can see, Wavefront, VRA, VMC, all of these are provided to us by VMware. And I'm using NSX-T in this demo today, which is provided by VMware. So you can kind of see where VMware gives us these providers and then manages and maintains them. But it's not necessarily managed and maintained by HashiCorp. So it's not a verified provider, but it does get the job done for what you want to do. There's a third level that's not being displayed here, which is the community. That's kind of the Wild West of the providers. You don't really know what you're getting into, and it's very, very, very open source. It's kind of like the hipster area, and you can really find some interesting stuff there in order to do some things with Terraform. But that leads to another number of questions about utilizing it within your environment that you would have to kind of figure that out yourself. But here's, a list of different ones that we have here. You can see, VMC, VRA, NSX-T, VCD, and you see 2 different ones, one for VRA and one for VRA 7. So you can use VRA 7 with these different ones as well. So that's a little bit about Terraform. Let's talk a little bit overarching just about the governance, the policies, why I believe DevOps is awesome and everybody should do it. And I always like to do this talk about this analogy here because I literally lived this. Because I always talk about Jack, the developer. And Jack is trying to build a new application because his manager told him he needs to build a new application by the end of this week or run some QA tests on it, right? So Jack's like, okay, I need some new machines that are built into dev and I need to start utilizing it. So he creates a ticket or a phone call or what have you. He communicates to the team that builds those servers and says, hey, I need some servers. And then Jack starts waiting. Well, as days go by and he doesn't get any responses, or maybe he gets a response that says, hey, we got the ticket, like 5 minutes after he sent the ticket, but he has had no response since. He starts wondering, where's my infrastructure and what is going on right now? Where's the disconnect that's happening while I'm waiting to get that infrastructure? I'm following the proper procedure. I'm following what ITIL tells me to. I'm following what the change advisory board is telling me to. This is the process, right? So for Jack, he starts thinking this waiting process isn't waiting. It's just a brick wall. It's this void of complete emptiness that he's thrown this ticket into, and it's never going to happen. So what's Jack going to do? He's still got a deadline that he has to meet. So this leads into Shadow IT, where Jack says, okay, well, I'm going to go into this public cloud. I'm going to create a free tier account and just spin up some free tier machines that I can just easily start using. And by going into the public cloud and starting to utilize this, he immediately has his infrastructure. And for Jack, he creates his application or QAs for that application, however he needs to do it. goes back to his boss and says, here you go, boss. Managed to get this done. I'm sorry I wasn't able to get it done on-prem, but I can tell you the application looks good or doesn't look good, however the outcome is for Jack. And what just happened is that this individual no longer believes in ITIL processes or change advisory boards or anything, because what he just saw is that instead of going through this process that has been used by legacy businesses everywhere, which is terrible and doesn't work, this is the only process that anybody should ever do. So Jack is no longer just not okay with ITIL and CABs. Jack is now an evangelist for a platform as a service solution, such as the public cloud. So where do we go from here? Why is DevOps solving this solution? Well, when we look at vRealize automation as an example, it fits itself right within that pipeline, right? It's not trying to change ITIL and it's not trying to change CABs. All it's trying to do is fit those policies and procedures within the pipeline that it already currently uses. So for instance, in vRealize automation, it uses infrastructure as code with the cloud assembly to build the solution, but it uses Service Broker as a front end so that Jack as a customer can click a button and get his machine built. Fun fact is the backend utilizing vRealize Orchestrator as well as other API calls that can be utilized within this product can actually attach into different ITIL tools such as Manage Engine, BMC Remedy, ServiceNow, so many different ones that are out there because it's a custom built API tool. In that way, it doesn't just build machines and outskirt the policies and procedures that the businesses have, but it embeds itself within those policies so that by doing it, the culture continues to grow, because what you've just done is you've started to evangelize this not only for Jack, but for your security people, for the ITIL management team, for the entire CAB. I bet they're a lot happier to see less changes coming through the pipeline. Well, when we talk about Terraform, it does very similar to the same thing. It has a specific tool for policy, which is known as Sentinel. It's not that you can use to kind of write these things. Obviously, I don't say that tools like that are a replacement for CABs and ITIL processes, because that will get you into a lot of trouble. But working with the people that utilize those policies and procedures and helping embed them into those, creating those policies within this and showing them how it works is extremely powerful. And it starts that culture change that a lot of people are looking at to help move a business from these legacy systems into a more DevOps mindset. The only thing that Terraform does that's different is it configures your state. So it doesn't actually just run on a request base. It runs on a full extent kind of base, I guess you could say it that way. So it understands everything that you want to build, and then as you continue to build onto it. So for instance, if I'm doing a WordPress build and then I just copy and paste another couple of machines and I change the name on those machines, it would just know to build more machines. And I can just continue to build upon that manifest, and it just continues to grow and grow. And so companies such as, I believe 1Password was the example, just decided to wipe out their entire production machines and rebuild it all in Terraform. And that way they could manage it from the ground up. And it's idempotent. So after they click the button to build them all, say something happens and it wipes all of their stuff via ransomware or whatever you want to call it, they can wipe it, every single machine there, and then click a button and everything starts rebuilding. And so obviously there's a lot more into ransomware in terms of where their injection and things like that. I don't want to get into that discussion, but that's just a use case that I have seen. So the reason why I bring this up is because I'm a vRealize automation guy. And like I said, in a couple of weeks, we're going to see how these two work together within the vRealize automation plugin for Terraform. But here are some things that you can see where they're side by side and see how they kind of work with each other. You can see that there is a plan, deploy, destroy phase within vRealize automation that you can utilize. It's not as friendly as Terraform, but it is a functionality there. But again, when we talk about this later on, we'll see how these two really kind of merge and marry with one another and really bring in the strengths of security and for your variables as well as your backend in visualized automation, and use the usability of Terraform's infrastructure as code as the front end, and really see how those two mix well with each other. So this is a fun tool that you can use with Terraform, which is Terraform Graph. So what it does is it goes through your manifest of everything that you're trying to build, and it gives you a picture of what it sees. You can see here, this is kind of an eyesore because it's a lot to take in. You can see how you're seeing different root accounts, different providers. You'll see some var dot statements, so those are variables. You'll see some data dot statements. And those data dot statements are basically data blocks, and we'll take a look at that in just a second. So you can see how everything kind of intermixes with each other and builds on top of each other. And then at the end, you know, you got your outcome. So I think I've slide decked a little bit too long. So let's get into some of the fun stuff here and see what this looks like. All right, so I am going to be using infrastructure, I've got infrastructure as code on the brain, but I'm going to be using Visual Studio's code here. Let me clear my screen so we can get that out of the way. And I'm going to move over to one of my main manifests here, and we'll start looking at that in just a second. You can see here, I've got a number of different files, and we'll go through what they do to a certain degree within a second. But I wanted to show you the main commands that you would use for Terraform. One of them is a fun one. It's just Terraform FMT or Terraform format. When you run Terraform format, what it does is it goes through your manifest, and it's very similar to a linter, but I wouldn't say that it is, because what it's trying to do is verify that you don't have any legacy statements within it, right? You want to make sure, it wants to make sure that you're not using interpolation, which is a curly bracket and then, or excuse me, a $, then a curly bracket, and then you have a variable within that, or a data block within that, which ends with another curly bracket, or strings where they don't need to be. For instance, here you can see the name that I'm using here is a string, but with different versions of Terraform, it has different things that need to be strings, different things that don't. So by using Terraform format, you can see how you no longer have to deal with that as well. So the first thing you're going to run with Terraform is just Terraform init. So this initializes what your manifests are, finds the providers that are necessary, and pulls them down. So you can see here that it's pulled down the NSX provider as well as the vSphere provider, and it gives you a version number for these things. Within your provider block, you can specify a specific version so it knows what to pull. And if you're using this within an air-gapped environment, for instance, you can utilize this to a local repository so that if you're pulling it to that location, it's just going to pull to that specific location. This is all within the provider block. I'm not getting into that very much within this because I'm not in an air-gapped environment. So I'm just, every time I init, it pulls down it from the, the HashiCorp repo for this. The next one you're going to probably run is a Terraform plan. And what a plan does is it goes through all of the different blocks that you're trying to build, and it goes through the providers that are necessary and says, okay, I see this, and this is what I'm going to build. And you can see here at the end, 7 to add, 0 to change, and 0 to destroy. That goes to a statement for the state file, right? Because if it knows what's in the state file and it knows what's already deployed, it knows what could be changed and what could be destroyed, right? It's not just sending things out to add, it has that understanding of what could be changed or destroyed. So this apply is going to take a while, so I'm just going to go ahead and apply this right now. And this is going to run through the plan process again, and then say yes if you want us to apply it. I'm going to say yes. There we go. So it's going to start creating some NSX-T parts, and then it's going to start deploying some things for the vSphere parts. And if I go over here, you can see that it's already starting to clone my template and spit it out to the necessary resource block. So as that's running, and like I said, this is going to take a little bit of time. I'm going to start going through some of these blocks here. So one of the things that I wanted to point out is that I'm using variables in order to run this manifest. Now, you can use variables in multiple different ways. You can use them as an environment variables, as a variable within a var file, which is what I'm doing here, or you can use variables within, an outsourced or a third-party secrets vault, such as Vault. There are multiple ways that you can do it with varying levels of security. In this demo, like I said, we're just using kind of the basic ways of doing it here. And the other reason why I'm not using an environment variable is because if I was using an environment variable, I would have to type it in as clear text within the terminal, and I'm just not feeling that way. But when we look at these blocks of codes here, that's literally what they're called. They're called code blocks, and this is known as a variable block. I'm using Visual Studio's code with a Terraform extension so that it kind of helps me work through this, and it'll have some pieces that will help you see things a little bit easier based off of its colors, right? For instance, if this is a variable block, excuse me, this would be a provider block, and this is where those providers come in, right? So this particular file that we're looking at here is specific to vSphere and NSX. That's just calling out and trying to get information for vSphere and NSX and making sure that the authentication for those places work. So for our vSphere, you can see here I'm using this var, and when Terraform sees the var, it's going to look immediately for a Terraform var file. And then if it sees that var file, it's going to pull that variable into this location. And a var file looks very much like this, except it has a value underneath it so that it knows what to spit out here. So you can see here that the provider for vSphere is very basic, I would say, because you can see a lot of different providers in different ways. Just user password, what the server is, and then allow unverified SSL, depending again with security, you can have that as true or false. And then we'll keep going down here a little bit, and I'm going to skip a bunch of these data blocks. We'll go back to those in just a second. But I wanted to show here where this provider for NSX-T block right here, it is much different. You can see it has a lot of different values, and that kind of goes again to the type of provider level that you're using, right? Because not all providers are the same. So if you're using for instance, if I'm using a vSphere provider and I say, okay, this is what I use for vSphere, I want to go use this in AWS, or I want to go use this in Azure, you can't use the same var file and just change the values in order for it to work. You'd have to make sure that you have all of the required contexts for that provider in order for that provider to initialize correctly. You can see here with NSX, just all of the different ones that I have here that are connecting, that are used to make sure that it connects to that provider. Excuse me. So the next thing I wanted to show is what's known as a data block. And these are these blocks right here that show data. Now this is really interesting because it gets into that declarative set of information. It knows what a vSphere data center looks like and knows what that object looks like. And so it's going to look for a vSphere data center with this name, with this specific data center right here. And once it's authenticated into vSphere, it's going to find that data center object and pull it in. Now here's the cool part about it. When it pulls in that data center object, it pulls in all the attributes of that data center object. For instance, now I can use that as a data center ID, which is utilized for all this other data that I'm pulling in for networking, for the resource pool, for the data store, and for the template. So you can see how all these different pieces kind of build on each other and help you deploy this in a better way than you trying to provide all of this information. Because instead of doing it this way, I could use this and then store static values here in order for it to pull this information, and that would work. But do I really want to do that? Do I want to have to change those values for everyone that I do, or do I want to just change this one value and it just trickle down? So it kind of shows how the tool allows you to pull that data into your manifest, into Terraform, and then allows Terraform to build on top of it. And this gets into a little bit about the explicit depends and the non-explicit depends within Terraform, because it has an understanding of what it needs to pull, what it needs to learn, and what to do next. And so it kind of makes those decisions within those contexts. And so in this particular manifest, I'm actually using a explicit depends on for the SQL box, because I want to make sure that the SQL box is up and running and good to go before the web front ends start building. And that's by design, because of course, once the web front ends are built, they have to connect to that SQL box. And if you're looking at the terminal now, you can see that it's now doing the provisioner statements, which I'm using for this. We'll talk a little bit about provisioners when we get to the Windows, when we get to the VM files. So let's move over to NSX. And I don't want to spend too much about NSX right here, but I just kind of want to show how these resource blocks are built. So we talked about data blocks, we talked about provider blocks. This is when we get into resource blocks. And for instance, here we're looking at, a load balance pool, right? So again, this is the type that we're looking at, and then these are all the required parameters that we have to input in order to create that particular resource. And again, these build on each other. So for instance, at the top, I'm actually pulling in specific tier 0 network by edge cluster and the TZ overlay. So I'm pulling in all of the transport zone. I'm pulling in all of that information and then understanding what that information is and then injecting it within resource blocks so that additional components can be deployed. So it looks like our SQL box finished, and now we can see, if I hop over here, we can see 2 web boxes are now being spun up. While those are building, let's take a look at our machines that we're deploying here. So this is very specific to building vSphere machines. For instance, again, these are resource blocks. And I will give you a little bit of a tip in terms of deploying resources. Resource blocks can get pretty long. And so I really stress using a good code editor in order to do this, because it helps you understand, these particular lines are extremely critical because you'll start thinking, oh, this is another resource block, or it's not indented, or it has this other problem. And you kind of lose track of where you are and what you're really doing. Because Terraform has an understanding of components within that resource block. And so when you're building these resources, it pulls a whole bunch of pieces of information from multiple different places and builds that resource in the way that it should. So for instance, one of the things I wanted to bring up here is this clone right here, this template UUID is a data block that we called in our vSphere file. Which was down here. So I don't have to put that within the same file. It knows all of the manifest files that are out there, and it knows all the data that it has as it's compiling it, and it can use it in different areas for these solutions. And you can see some other basic data like number of CPU and memory, the disk information here, size, then provisioned, all those different things, right? And then we have some customization options. This is where you can use your customization specialization in vSphere in order to run that if you wanted to use something like that. I'm currently not using that. I'm using provisioners in order to deploy this, just to show what that does. And provisioners are a very interesting thing. So Terraform is very focused on infrastructure as code. When you get to the OS layer, Terraform has a very hands-off approach because they don't really want to control the operating system. They don't really want to help in that area. They've basically given you WinRM and SSH and kind of walked away and said, okay, if you're going to do the operating system, use Chef, use Puppet, use one of these other solutions. But this is what will allow you to have and have fun with those. So you can use these in a demo environment, such as what I'm using, or development. But again, security is that question. Are you okay with having those ports open for SSH or WinRM? And are you okay with pushing files and packets and doing remote executables on those? And just real quickly here, I can show you the blocks where this is just a provisioner for a file, where I'm basically saying, okay, I want you to take this file, which is currently on this machine right here. And I want you to take this file. I believe it's right there, the SQL.sh file that's right here. And I want you to push it to that machine, and I want you to put it in the temp SQL.sh. And then I want you to run a remote executable that changes some ownership and then runs that command. And then from there, that bash script basically sets everything up for me. Now, the provisioners for file and remote exec only get you so far, but they won't actually work at all unless you use a connection block, which is what this part right here is. So this is where you're basically stating what type of connection you are, which is WinRM or SSH. You're saying what the username should be and password, which is what I'm using here, and then where that location is. And this is interesting because you can see here, this is not a data or a var. What this is basically I'm calling the resource, which is the vSphere virtual machine, and then which resource that is the vSphere virtual machine, which is SQL, which is this particular resource. And I'm using its default IP address in order to connect. So basically it's building that machine. And then once it knows what the IP address is, it's connecting to that machine, and then it's pushing the file, and then it's executing that file onto the machine. And as you can see down here, as it's building and pushing that file and running all of these scripts, we actually have a kind of a terminal zero effect in order to see all of these things actually be deployed. So that was the SQL box. And I don't really want to keep going through the web ones because they're basically almost the exact same things. But the one thing I did want to show, it's always at the bottom. Oh, there it is this depends on statement. So this is the example of explicit depends. And like I mentioned before, the only reason I'm currently using this is because, I've ran into times where the SQL machine isn't built at the right time as the web machines. And since this is a live demo, I don't want to kind of roll the dice and see what happens. I really wanted the SQL machine to be built and to be finalized before anything is built on top of it. And so that gives you kind of an understanding of the different components that are using for the manifest for vSphere, NSX, as well as some of the things that I'm doing with the machines themselves. Now, moving over here on the left, I just want to point out one thing. If you see this terraform.tfstate.lock, that is a very important thing because what this is literally locking the state file. Now, in open source, if I'm running Terraform apply and it's doing all of these different things, no one else has access to the state file to do a plan or an apply or a change. It's a very interesting way of dealing with state. And when you work with different repositories, you can see how there are push battles or pull, all of these different changes with a single repository and who pushed their change first and all these different things. It kind of gets a little hectic. Terraform's response to it is just lock it and say, okay, someone's doing an apply right now. No one else can touch it. Now, You can change that and say, I don't want you to lock it, but be very warned by what will happen if you do that, because if you don't lock it when you're running something, you can very easily corrupt your state file and run into some very big problems by doing that. So something definitely to think about. And let's see here. I think my boxes should be finishing up rather soon. Looks like they're running right now. So we're just waiting for them to create the connection, and then it should kick off the 2 file builds for it by the SQL.sh and the WebSH boxes scripts. And these are just basic bash scripts that are, installing SQL and making it set up for the WordPress application. And then, web is just installing Apache and then connecting that web front end to the SQL backend. There we go. So now we can see the provisioning with file, and it happened really, really, really quick. But what you saw really quickly was it was trying to connect, and it will do a connect retry to a certain point. It'll try a number of times in order to make sure that it can connect to it. But this is a really interesting situation, and I'll bring this up a little bit so you can see more about what's happening. But what you're actually seeing is both the Web 1 and Web 2 output into the single screen. And you'll see it when you look at vSphere virtual machine.web, and you'll see 1 and 2 popping up at the same time. So it's kind of hectic because if you're trying to use this as a troubleshooting or a logging, it can be a little bit difficult to parse. Obviously, grep and all of those tools are available so you can work through those things, right? But you can see again here where it's finishing up some of the script, it gets even more hectic with the different things that it's doing. But it should be finishing up here. I apologize. For some reason, these were just running just slightly behind the last time I timed it. But within a couple of seconds, these should be done, and we should be able to show our application is completed. What a difference a minute makes. Yeah, it's kind of interesting how the final parts are built really quickly. The virtual machines take up the most amount of time. And so here we show our apply is complete. We've added 7 resources. We have changed 0 and we have destroyed 0. And one of the things I'm going to do is if I go into my load balancer in NSX, I have specified a very specific IP for it. And so right here, we can see it's 10.150.166.5. I'm just going to copy that, and I'm going to paste it in here. That should hit the NSX load balancer, which leads us to our web front end, which is running Apache. And then I can connect here to my WordPress application, or I should, fingers crossed. There we are. Okay, so for those that have ever deployed WordPress know that this screen only comes up if you have a successful connection to the backend database from the front end. And so all of the data is flowing properly for this application. And all we have left to do is kill everything and destroy it. So if we go Terraform destroy, it goes and looks into that state file, it locks it as it's pulling all of the information. And then it says 0 to add, 0 to change, 7 to destroy. And I am just an absolute anarchist. So I say yes, and then, goodbye to everything. And we can even go over here to our vSphere, and we see all of the deleting happening here as well. And the destroy takes far less time than the apply, and we'll see everything just crash from there. And that's what I have. I very much appreciate everyone's time. And yeah, if there's any questions, I'd love to take those now.
Nathan, there is a few questions here. The first one is, what qualifications should we use when choosing a provider?
Yeah, so that's kind of tricky. I'd love to say it depends, but that's kind of an IT cop-out answer. Really pay attention to where that provider is coming from. If it's a community provider, version it. because those community providers can break things just as quickly as they add new things to them. So if you've got something that's working in a community provider, you definitely want to keep it on that version. And so you would want to put that within your provider block to say only this version. And that allows you a lot more usability to it. When it gets to the open source and the verified HashiCorp providers, those obviously have change documentation as well as help and things like that within specific GitHub repos. And so you can definitely contact them with anything that's broken or any issues.
Great, thank you. And then the last one is, where can we learn more about Terraform?
Yeah, so Terraform has a great learning platform. When I first started working with Terraform, there wasn't a huge amount of stuff, but they've really grown that to allow for a number of different things. And I think it's like either learn.terraform.com or learn.hashicorp.com. Something along those lines, but I'm sure you can just Google it. But their learning platform is absolutely fantastic to learn these solutions. And, like I said, we'll see how Terraform is then built onto vRealize automation, and then you can use those manifests in that way, which can allow you for a lot of different things. So, yeah.
I did find that link you were just talking about. So I did put that in the chat for anybody who would like to copy and paste it and learn more about Terraform specifically. And if you have any additional questions, please feel free to reach out to the Sterling team or Nathan specifically as well. Thank you so much, everybody, for joining today.
Thank you.